All right, this is a video going over several questions from the Unit 5B review. I'll try to go over at least one of each type. So first, divide using long division. Okay, so we'll put our divisor here on the outside, 3x plus 1. On the inside, we're going to put our dividend, that is negative 6x cubed. Make sure no terms are missing. If there is a term that is missing, such as if there were no x squared term, you'd want to insert a 0x squared there. Same thing with the divisor. If there were a term missing there, you would want to insert a 0 for that one as well. Okay, so first we divide. We're saying what is negative 6x cubed divided by 3x. Always just look at the first two terms that you're dealing with. Negative 6x cubed divided by 3x gives you negative 2x squared. Okay, so you divide, then you multiply. You multiply this negative 2x squared times 3x plus 1. So distributing that to the whole thing there. So negative 2x squared times 3x gives you negative 6x cubed. That's what you want to happen. You want those two to be exactly the same. Okay, and then negative 2x squared times 1, because you're distributing that to both terms there. So that gives you negative 2x squared. Okay, and then you're going to multiply. We just multiplied. So the steps are divide, multiply, subtract, bring down. So the next step is to subtract. Some people like to just say, okay, negative 6 minus negative 6 is 0. Some people like to take that negative and distribute it here. So that becomes a plus, right, if I distribute that negative. Or maybe you learned in Algebra 2 the phrase, change the sign, draw the line. So then you're changing both signs there. Both of them become plus in this case, and then you draw the line. So now I have negative 6 plus 6 is 0, that cancels. 4 plus 2 is 6. So 6x squared. Several people asking me today what happens with this exponent. Remember, you're just combining like terms. So your exponent is not going to change. You're just adding the 4 plus 2 is 6. X squared just comes along for the ride. It's not going to change. Okay, now we bring down the 17x. And start over. So divide. 6x squared divided by 3x gives you 2x, positive 2x. Multiply 2x times 3x plus 1. Distributing that. Subtract. So you could just change both signs, draw the line. You could put a minus there and distribute it. Whatever makes sense to you. Just make sure you're subtracting. So 6 minus 6 cancels. 17 minus 2 gives me 15x. Then I bring down this 5. And start over. Divide. So that's 15x divided by 3x. That gives me 5. Multiply. 5 times 3x is 15x. 5 times 1 is 5. Then we subtract. So we're going to change those signs there, distributing the minus sign. 15 minus 15 is 0. 5 minus 5 is also 0. So this one has a remainder of 0. So your answer, your quotient, your answer is negative 2x squared plus 2x plus 5. Right there. All right, I'm going to skip number 2 because it's similar enough to number whoa, wrong page. It's similar enough to number 3. Okay, so let's set this one up. Long division once more. Okay, so on the inside, I'm going to put my dividend, 4x to the 5th. Notice there's an x to the 4th missing there, so make sure you insert a plus 0x to the 4th. Okay, minus x cubed plus 5x squared minus 89x minus 25. Now the part that messes most people up on this problem is inserting your 0x here, right? Even for the divisor, you want to make sure all of your terms are there. So this is x squared plus 0x minus 5. So make sure you insert that. And that actually makes the problem a little easier in my opinion, because this time we're actually going through 3 terms at a time with that, since we have 3 terms in our divisor. All right, so we divide 4x to the 5th divided by x squared, just looking at our first 2 terms always. That gives you 4x cubed. Multiply 4x cubed times this entire trinomial, so distributing that. 4x cubed times x squared gives you 4x to the 5th. 4x cubed times 0x gives you 0x to the 4th. 4x cubed times negative 5 gives you negative 20x cubed. All right, now we change the sign, draw the line, or you could think of it as just distributing the minus sign. 4 minus 4 cancels, 0 minus 0 is 0, and then we have negative 1 plus 20 gives us 19x cubed. Now, because 2 terms canceled on that step, you can actually bring down 2 terms. 2 terms canceled, 2 terms come down. And we start over. Okay, so looking at your first terms again, 19x cubed divided by x squared. That gives me 19x. I'm going to multiply, distributing that to all 3 terms. Uh, 19 times negative 5 gives me negative 95. So negative 95x. And we're going to subtract now, so distribute that minus sign. Cancels, 5 minus 0 is still just 5. Negative 89 plus 95 gives us 6. Bring down the minus 25. And you just do it one more time, okay? So we've got 5x squared divided by x squared. Looking at our first 2 terms, the 5x squared and then the x squared in your divisor. That gives you 5, so plus 5. Multiply that 5 times your divisor, so 5x squared plus 0x minus 25. Now don't forget to change your signs here. Minus becomes a plus. 5's cancel, 6 minus 0 is 6x. And then negative 25 plus 25 is 0. So your remainder is actually just 6x. So you're going to put plus 6x divided by your divisor, which was x squared minus 5. All right, so let's look at our answer choices and see what we have. This one at the bottom is almost correct, but notice that sign is incorrect. This one has an incorrect remainder. That's not going to work. Then we have 4x cubed plus 19x minus 5. That's not correct. So it must be A. I don't know why I put x's instead of checks there, so maybe check. Yep, that's what we got. All right. Synthetic division, I think we see enough in our other examples, right? Because we use it for pretty much everything else in this unit, for pretty much everything. So I'm just going to skip these, as we will see synthetic division right here on number 7. Okay, so remember synthetic division, so remember the remainder theorem allows you to find the value of a function at a specific x value, because the remainder is the value of the function. So when you do synthetic division with -2, the remainder is f of -2. So 1, 2, 4, 5, -7. Listing out your coefficients. Remember to insert a 0 anytime a term is missing. No missing terms on this one, so we're good to go. Okay, we're going to drop this 1, multiply. -2 times 1 is -2. Add. 2 plus -2 is 0. Multiply. -2 times 0 is 0. Add. 4 plus 0 is 4. Multiply. -2 times 4 is -8. Then we will add, multiply, and add. So since my remainder, that last number, is -1, that means f of -2 equals -1. Okay, and if you wanted to double check yourself, you could plug -2 in for x in your calculator and just make sure it comes out to -1. That's how you could check your answer there. Synthetic division should be pretty quick though. We should be getting really good at that. Also, just a reminder about synthetic division, these are your new coefficients. So if I wrote out the quotient here that I get when I divide, I'm going to go down by 1 degree. So it's going to be x cubed. And then these are your coefficients. So 1x cubed plus 0x squared, which you don't need to write because it's 0. And you have plus 4x minus 3. And then for your remainder, still writing that over your divisor. In this case, we were dividing by x plus 2. Right, put that back into the factored form, which would be x plus 2. So this would be the quotient if that's what they were asking for, like on the previous few problems. Okay, but we don't need it here actually. All right. So moral of the story, if you're using a remainder theorem to find the value of a function, you're looking at the remainder after you've done synthetic division. Okay, and that's all of those. Let's see the next page. Okay, nothing different here, remainder theorem. Now use the factor theorem to determine if a given binomial is a factor of f of x. So I'm trying to see, is x plus 3 a factor of f of x? Well, if I know the remainder tells me the value of the function, and if this is a factor, then x equals -3 should be a 0. X equals -3 should be a 0, which means it should give me 0 when I do synthetic division. So that's what you're checking. You're doing synthetic division, and you're checking to see, is the remainder 0? If it is, then it is a factor. If it is not 0, then it is not a factor. All right, so let's check. So to figure out what number goes in the box here, you're always changing the sign in front of the number. But let's say I had 3x plus 1 as the factor, then you would want to set that equal to 0 and solve for x. Okay, we don't really want to do synthetic division with -1/3, but if that were the case, if that were the factor that you were checking, that's how you would figure out what number to put in the box. You would do -1/3. Okay, just saying. All right, so we write out our coefficients, make sure no terms are missing. Don't see any on this one. We go 4, 3, 2, 1, 0. Okay, so we don't have anything missing. Drop the 1, multiply, add, multiply, add, multiply, add, multiply, and my remainder is 0. So this tells me that -3 is a 0 of that polynomial, and that x plus 3 is a factor. Okay, so just looking for a remainder of 0. Okay, We'll continue, find a different type of problem to look at. Okay, we can do this. Determine if the binomial is a factor. So same type of question, but your polynomial is a little different here. So this one, you're going to do x equals 7, right? You're going to put 7 in your box here. And then for part B, x equals -7. So you'll do -7 for synthetic division. Now, writing out your coefficients, you need to insert a 0x squared, a 0x, and that's it. So those are your two terms that are missing there in between the x cubed and the constant term. So you'll have 1, 0, 0, 343. Okay, so 1, 7, 7, 49, 49, and let's see what 49 times 7 gives me. 343, which does not come out to 0 because we're adding, right? That's 686. So no for part A. Okay, part B. So that's going to come out to -343 since I'm multiplying by a -7 this time, which means my remainder is 0. So B, yes, x plus 7 is a factor. So no, yes is what we're looking for. No, yes. There we go. Okay, use synthetic division and the remainder theorem to determine if these are, if this is a factor of f of x. Okay, so if we're using synthetic division, we're going to put this is our divisor, and we are going to divide that into our function f of x. So we'll use our coefficients, 1, -6, and 13. Drop the 1. Now multiply 3 minus 2i times 1. Anything times 1 is itself, so 3 minus 2i. Now we're adding here, so you're going to combine like terms. -6 plus 3 is -3. And then you have minus 2i. Multiply again, so I'm going to FOIL that out to the side. 3 minus 2i. Times -3 minus 2i, -9 minus 6i plus 6i plus 2i squared. I squared equals -1, so this actually is -2. Your -6i plus 6i cancels. -9 minus 2 is -11. So this just comes out to -11. Okay, and that means my remainder here is 2. So because my remainder did not come out to 1, it is not a factor. In order for a number to be a 0, the remainder has to be 0. In order for that factor to be a factor, again, the remainder has to be 0. All right. Okay, let's see what we have next. Suppose that a polynomial function with real coefficients of degree 4 with real coefficients has the following zeros. Okay, so I've got -4 minus I. If this didn't show up on your question, you might need to refresh the page. There was a mistake on this when we first published the review. This was missing for some reason. Okay, so if it has this as a 0, then the conjugate, -4 plus I, must also be a 0. So just changing that middle sign to get the complex conjugate. Complex numbers, non-real complex numbers always come in pairs. Just changing this middle sign. If I had 2i was a 0, then -2i would also be a 0. If I have 3 plus 4i as a 0, then 3 minus 4i is also a 0. They come in pairs. All right, number 16. Use synthetic division to divide f of x by x minus 8. Then use that result to find all zeros of f. All right. So first we're going to divide by x plus 8, which means we're going to put negative 8 in our box here. List out your coefficients, 1, negative 1, negative 52, and 160. Drop the 1, multiply, add, multiply, add, multiply, add. Okay, so since that remainder came out to 0, yes, x plus 8 is a factor of the polynomial, and negative 8 is a 0. Negative 8 is a 0, so that means I can cross out those two options, because remember, when you have a factor, you're setting it equal to 0 and solving for x to see what the 0 is. So if x plus 8 is a factor, then negative 8 is the 0. Now, these are our new coefficients. After I've divided by x plus 8, I have x squared minus 9x plus 20. Okay, so from there, I would just factor this to solve. We're looking for zeros, so you can just set it equal to 0, and now we will factor. So two numbers that add to negative 9 and multiply to 20. Maybe you want to list out your factors of 20. Okay, which ones would add to negative 9? Remember, they have to multiply to positive 20, so they have to have the same sign. So negative 4 and negative 5. So I have x minus 4, x minus 5. Set each factor equal to 0, and you get x equals 4 and x equals 5. So negative 8, 4, and 5. It's the same idea here on 17 and 18, and probably some questions after this, but you're given one of the zeros, and then you're asked to solve. So what you want to do is synthetic division. Synthetic division with 4. You should get a remainder of 0. Take the polynomial that you have left there and factor it, or solve, whatever method you want to use to solve that. Okay, so usually factoring, but let's say I have like x squared plus 9. I can't factor that because it's not the difference of squares. So I would subtract the 9 over, take the square root. So plus or minus the square root of negative 9 is 3i, so plus or minus 3i. That is not for number 18. I'm just saying in general, sometimes you can't factor it, but you can still solve. All right, same thing on 18. So divide out the 0 that they give you, and then factor what's left. Same thing on 19 and 20. All right, let's see what 21. Use the rational zero theorem to list all possible rational zeros. So this is where we're going to get our list of p's and our list of q's. And then you want all of your plus or minus p divided by q's. Those are your possible zeros, possible rational zeros for the function. So your p's are your factors of your constant term, in this case 21. So factors of 21 are 1, 3, 7, and 21. And then your q's are your factors of your leading coefficient, 1. So we've got plus or minus, and now we want to do all the combinations of p divided by q. In this case, it's pretty simple because we just have a 1 to divide by. So that's going to be plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. Those are your factors. Those are your potential zeros of the function. Same thing on this one. So your p's are going to be your factors of 2. Your q's are going to be factors of 7. Then you do plus or minus p divided by q. Same thing here and here. All right, now 25 actually asks to find the rational zeros of this polynomial. And so maybe you want to list out your potential zeros like we just did. So your p's are factors of 4. Your q's are your factors of 4 as well. And so your plus or minus p divided by q's are going to give you plus or minus 1, 2, 4. That's dividing all of my p's by 1. Now divide all of your p's by 2. That's plus or minus 1/2. 2 divided by 2 gives you 1, which we already have on our list. 4 divided by 2 gives you 2, which we already have on our list. So I'm going to move on to dividing by 4. That gives me plus or minus 1/4. And then the other 2 we already have on our list. So that's my complete list of potential rational zeros. So now you could go through that entire list and figure out which one gives you a remainder of 0, right? Because if it gives you a remainder of 0, then it is a 0 of the function. Well, our test is timed and whatnot, so what I would recommend is actually putting this polynomial in your calculator, 4x to the 4th, so you can kind of see which one maybe you want to start with. It's kind of just a little strategy to see which number should I do synthetic division with first, so that I'm still using this method, but I'm not wasting a bunch of time. Now, if we had taken away your calculators, you wouldn't have had that option, but it looks like I have -4 as a 0. You can see there. You can actually do second trace 0, which is 2, to see if it is a 0, but yes, -4 is one of my zeros. So I'm actually going to start by doing synthetic division with -4. Okay, my coefficients are 4, 9, -34, -25, -4. All right, so yeah, that one gave me a remainder of 0, so I know that that one is a 0 of the polynomial. Now, the polynomial that I have left here with my new coefficients is still not factorable, so I'm going to need to figure out another one of the zeros. Again, I could look at my calculator and see which one I believe is going to work. Let's see. I can't actually tell. So I'm going to move over here and see what this number is. So 0 at 2.4, that's nothing on our, so what that means is that's not a rational 0. It's going to be an irrational 0, such as the square root of some number. Okay, so that's not a rational 0. So you can check to see what the other 0 is. It's going to be -1/4 right here if you check that one. So I could do synthetic division with -1/4 here. I'm going to use my new coefficients, which are 4, -7, -6, and -1. Okay, see, I get a remainder of 0 again when I do synthetic division with -1/4. So I know -1/4 is another one of my zeros. So I have -4 and -1/4 so far. Then maybe we can try to factor this. This is 4x squared minus 8x minus 4. So that's two numbers that add to -8 and multiply to 16, -16. Factors of 16, 1 and 16. 2 and 8, 4 and 4. -4 and -4 add to -8, but they do not multiply to -16. They multiply to +16. So that won't work. There are no factors that are going to add to -8 and multiply to -16. So this is not factorable. And if it's not factorable, that means I'm not going to get any more rational zeros. You could plug it into the quadratic formula to see what the other zero is, but it's not rational. So since we're only looking for rational zeros here, we're done with -4 and -1/4. Okay. So same idea here. You can use synthetic division to factor this one, but actually if you pay attention, this one is factorable just in general. So if the directions say that you need to use synthetic division or whatever first, find a rational zero first, you do need to show that method on your work. However, you can also get the answer very quickly just by using grouping on this one. Okay, so you can use grouping to get the answer, but make sure if the question tells you explicitly to find a rational zero, then make sure you are showing your synthetic division on your work.